Hi guys, your Friendtor Gopika is here, and in this video we will discuss the concept of touching circles. Okay, so before starting with the definition, we'll perform two activities to know more about touching circles, and we will also discuss a theorem regarding the point of contact of touching circles and the line joining their centers. Okay, so without wasting time, let's get started. Okay, so this is activity 1. So the activity says take three collinear points x, y, z. Okay, that means they lie on the same line as shown in figure 3.22. So that is towards the right. You see these points x, y, z are collinear, and x is center of this larger circle and z is the center of the smaller circle. Now draw a circle with center x and radius xy. So the larger circle, the radius is xy, and for the smaller circle, the radius is zy or yz. Okay. Now note that both these circles intersect each other at single point y. Only common point between these two circles is point y. Such circles are called as touching circles. Okay. Now if you draw a line through this point y and perpendicular to xz, then that will be the common tangent to both the circles. Okay, so this line is tangent to larger circle also and the smaller circles. Now let's see the second activity. Again here points y, x and z are collinear as in the figure. Now you need to draw a circle with center z and radius zy, that will be the bigger circle. Next, take x as the center and xy as the radius, and you will get the smaller circle. And here also there is one common point for both the circles, and that is point y. So they are intersecting at just one point, that is point y. Okay. Now if you draw a line perpendicular to this xy or zy, then this line will be tangent to both the circles. It's common tangent for the circles. Okay. Since it is tangent to both the circles, we can call it as common tangent. Okay. Now let's see the definition. Touching circles. Touching circles can be defined as follows. If two circles in the same plane intersect with a line in the plane in only one point, then they are said to be touching circles, and the line is their common tangent. The point common to the circles and the line is called their common point of contact. So that point which is common to both the circles as well as which is lying on that common tangent, that point is called point of contact. Okay. So in activity 1 and in activity 2, we discussed two types of touching circles. One, in the first case, these two circles were lying outside, and in the second case, one circle is lying inside the other. So the first case, we can say that the circles are touching externally, and in the second case, we can call it as the circles are touching internally because it is lying inside. From internal side it is touching, and since here in the first case two circles are lying outside, they are touching to the external part. So first case the circles touch externally, in the second case the circles touch internally. So here that is what they have elaborated. In figure 3.24, the circles with centers R and S touch the line L in point T. So there are two touching circles with L as common tangent, and they are touching externally. In the second case, the circles with centers M, N touch each other internally, and the line P is their common tangent. Okay. Now let's see the theorem which talks about the point of contact and the line joining the centers of two touching circles. So the theorem is called as theorem of touching circles. If two circles touch each other, their point of contact lies on the line joining their centers. That means here in case A, if you join AB, that is A is the center of the first circle, B is the center of the second circle. If you join that AB, then on the same line you will get C, which is the point of contact of the two touching circles. Similarly here, in the second case, if you join AB, now AB here we need to extend the line. Since it is internally touching, C is outside AB. So if you extend this line AB and extend this line, then you will see that C lies on the same line. Okay. So in short, theorem of touching circles say that the centers of the touching circles and the point of contact are collinear. That is, in both cases A and B, points A, C, B are collinear. Okay. So let's start with the proof. So before starting, what is given? Given C is the point of contact of the two circles with centers A, B. To prove that points C lie on the line AB. So point C lies on the line AB. That is what we need to prove. The proof starts here. The line L. Now if you see, in both cases line L is the common tangent. Correct? C is the point of contact and line L is the common tangent. Now passing through this C of the two touching circles, here if you see, this line L is perpendicular to AC by tangent theorem. Since in the beginning of the chapter we learned that tangent theorem says every tangent is perpendicular to the radius at its point of contact or through its point of contact. Here this line L is perpendicular to AC, which is radius of the first circle, and line L is perpendicular to BC, which is radii of the second circle. So by tangent theorem we can conclude that. Now if AC is also perpendicular to the same line, BC is also perpendicular to the same line, that means through C only one line perpendicular to line L can be drawn. Now with that, it concludes that A, C, B should lie on the same line. Okay. So from the left side also AC is perpendicular to line L. BC is also perpendicular to line L. And through one point, if you draw a line perpendicular to L, then all these 3 points should lie on the same line. That is what we can conclude. So for both cases, this proof is true. Here also, if you see, if you draw a perpendicular like BC if you join and AC if you join, both of them are perpendicular to same line. Now to one single point, we cannot have two perpendiculars drawn towards us towards the same line. That means these two lines are collinear. It has to be lying on the same line. So points C, A, B are collinear. Okay. So once again we'll go through the proof. So the proof says AC is perpendicular to L by tangent theorem. BC is also perpendicular to line L by tangent theorem. Now through C we can draw only one perpendicular. One perpendicular can be drawn of line L through one single point. That means this ACB should be lying on the same line. Okay. So hence they are collinear. So that's it. So in this particular video, what we learned? First we learned we discussed two activities, and then we learned what are touching circles, what is meant by touching externally, what is meant by touching internally, and then we learned one important theorem regarding their point of contact and the line joining their centers. So let's revise it. First point, the point of contact of the touching circles lies on the line joining their centers. Second point, if the circles touch each other externally, that means the case 1 where two circles were touching from the external part, they are not lying, one is not lying in the other, both are lying outside. Then the distance between the centers will be radii of the first circle plus radii of the second circle. So if you just add the radius of both the circles, you will get the distance between their centers. Whereas in the second case, the distance between the centers of the circles touching internally, where one circle is lying within the other, is equal to difference of the radii. That also, the larger radius, if you subtract from larger radius, if you subtract the smaller radius, then you will get the distance between their centers. So these three things we will be using in the next practice set 3.2. These three concepts we will be using, and then we'll be solving the questions. So I'm done with the video. In the next video, I'll be discussing the practice set 3.2 problems. Okay. If you like the video, please share it with your friends and please subscribe the channel. You can also follow us on Instagram at s_g_friendtor. Thank you.